All right, so we are going to continue on with multiplying polynomials, but in 7.3, we are going to take a look at these special products. Actually, not products, special product. We only get one product. Polynomials. Special product polynomials. First one we are going to look at is what's called square of a binomial pattern. These are going to have a very specific pattern, just like when we were foiling or we were multiplying double distribution, a binomial times a binomial, which product was a trinomial. Sometimes we may have something that looks like that. A plus b squared, which is simply a plus b times a plus b. And you could certainly FOIL this out. But what happens when I have something times itself, a binomial times itself, a little pattern develops. And that pattern is I take what's inside the parentheses, the value of a, and that is squared. Then I take a times b and I double it. A times b is just ab. And if I double that, I have two of them. And then I square my b term. So it would be plus b squared. And if I think about how this FOILs, a times a would be a squared. A times b would be ab. B times a is ab. And look at that. I have an a times a b and an a times a b. You have two of them. And then you would multiply b times b, which is b squared. The same thing is going to happen when I have subtraction. I could just switch this to a minus b. All that's going to do is change my middle term here to a negative. The b squared will still be positive because it'll be a negative b times a negative b. So my pattern for this is just a squared minus 2ab. This is still going to be plus b squared because remember, this term comes from the multiplication of my two last terms, and a negative times a negative is a positive. Because I could certainly say this is a minus b times a minus b. I didn't write it, but hopefully you're seeing that. A times a is a squared, negative ab, you've got two of them, and then negative b times negative b is a positive b squared. Three x plus 4 squared. I'm going to do this using the pattern. I take my first term and I square it. This is a. So this is 3x squared plus 2 times 3x times 4. And then plus your b squared, which is 4. And I will simply square that. Now, 3x squared, remember, is 3x times 3x. This is where rules of exponents come in again. 9, and then same base, add my exponents, that's 9x squared. Or I could do power to a power. 3 squared x squared, which is 9x squared. Parentheses first, 3x times 4, 12x times 2, 24x plus 4 squared, which is 16, and I got it. If you are in doubt and you are not picking up on the pattern, you will not go wrong by doing double distribution or foiling. But you're going to pick up on the pattern. When you do several of these, like on your homework, over and over and over, you will begin to pick up on the pattern. Some students never do, and they just continue to FOIL, and that's fine, but I'm just waiting for the light to go off in their head and say, you know what, it's easier to use my pattern. If I FOIL 3x times 3x, 9x squared. 3x times 4 plus 12x. 4 times 3x plus 12x. 4 times 4 plus 16. Again, these are going to be the same. That's why we double it. And I still get 9x squared plus 24x plus 16. And I got it. Try this one. 5x minus 2y squared. Nothing is going to change. This is still my A, this is still my B. I can still use my pattern to solve this. I just got to make sure to take care to put my y with it. Again, if I use the pattern, I take the A term and I square it, which is 5x, minus 2 times, I have 5x times 2y, plus my B term, 2y squared. Why is this plus? Because it's going to be a negative times a negative. This will be negative because you are adding two negative numbers. That's why it was negative up here and why it is down here. 5x times 5x, or 5 squared times x squared, that's 25x squared, minus 5x times 2y. 5 times 2, 10. 10xy, and I double it. Plus 4y squared, and I got it. And again, I can always write this out. This may be the last time you see me do this, because I'm going to definitely use the pattern. 5x times 5x, 25x squared. 5x times negative 2y, negative 10xy. 2y, a negative 2y times a positive 5x, negative 10xy, and then negative 2y times negative 2y, positive 4y squared. And again, I've got the same term, and that's why it's doubled here. Negative 10 subtract 10, negative 20, and I've got my xy. So I get the same answer. But I'm telling you, we want to be able to recognize that this is what we call a perfect square trinomial. And what I mean by a perfect square trinomial is my eyes need to start going to these two terms right here. When these are perfect squares, which 25x squared is, what times itself gives me 25x squared? 5x times 5x. It is a perfect square. I can take the square root of it. The square root of 4 is 2. The square root of y squared is y. These are perfect squares. It's just something to stick in our toolbox to use later. I'm going to pick up the pace a little bit and show you what I expect us to be able to do. Eventually. Here's how I do these. 7x minus 3 squared. I am not writing this out and I am not foiling it. I'm not even going to write out this pattern anymore. I am going to walk through how I do this. I take the first term and I square it. 7x times 7x. Well, that's 49x squared. I take 7x times negative 3. 7x times negative 3. Negative 21x. But I double it. Negative 42x. Negative 3 squared plus 9. And I got it. I took my A term and I squared it. I took my A times my B and I doubled it. And then I squared my last term and I got it. I could have something that looks like this. but the pattern is the same. 3m plus n squared. 3m plus n times 3n plus n. I take my first term and I square it. 9m squared. I take 3m times m, 3mn, and then I double it. 6mn, and then I square my b term plus n squared. And I got it. And again, paying attention to, this is what we call a perfect square trinomial. 9m squared, I can take the square root of 9. The square root of 9 is 3. The square root of m squared is m. The square root of n squared is n. n times n gives me n squared. I'm paying attention that these are perfect square trinomials. What we are going to look at, lastly, is what we call a sum and difference. Sum and difference binomials. One is going to be addition, one is going to be subtraction, and my terms will be the same. What do I mean by that? I mean a plus b times a minus b. What's going to be the same are both of these. What's going to be different is one will be plus, one will be minus. A sum and a difference, an add and a subtract. That multiplies to be this. A squared minus b squared. And I want us to look at what happens when I have something like that. Let's say I have x plus 3 times x minus 3. Now, if I look at just what's here, it's a squared, x squared minus b squared minus 9. Notice, there's no middle term. And there's not going to be a middle term because my middle term comes from the sum of the products of your outside negative 3x and your inside positive 3x. And what happens when I take 3x minus 3x? Well, that is 0. That's why my middle term goes away. If I FOIL this, x times x is x squared. X times negative 3 is a negative 3x. Bam! Here comes that positive 3x. Positive 3 times negative 3, negative 9. Notice, in the middle, that is going to be 0. That goes away. Here's what you're left with. X squared subtract 9. And again, if you just use your pattern, and this is x plus 3 times x minus 3, I have a sum and difference. I know it's going to be x squared minus 9. I square my first term. There's subtraction in the middle because it's positive 3 times negative 3. There is no middle term because you are going to add it and then subtract it. And I know anything subtract itself is always 0. T plus 5 times t minus 5. T squared subtract 25. First term squared, second term squared, subtraction in the middle. You might have something that looks like this. 3x plus y times 3x minus y. Again, my terms are the same. There's subtraction and addition. I have a sum and difference. I'm not going to have a middle term. I take my first term and I square it. I'll write this one out. Minus y, and I square it. 9x squared minus y squared. The last thing I want to point out to you is a couple of problems that are in your homework. And our job is to use a special pattern to find the product of 36 times 24. And there may be one like this on your quiz. And you certainly can't just put this into your calculator and tell me the answer. You can't even just do column multiplication, 36 times 24, and do the math. It says to use a special pattern. And the special patterns that we have talked about are a plus b squared, a minus b squared, and a plus b times a minus b. That's what I'm going to use to solve this, one of these. Now when I'm looking at this one, this is the multiplication of two numbers. What I like to think of as this one is, what number is right in between here? What's halfway in between? Well, if I have 36 and 24, 30 is my middle number, right? 36 is 6 above. 6 below is 24. In your homework, when you see this multiplication, it's going to key you in to use a sum and a difference. This would follow this. This would be 30 plus 6 times 30 subtract 6. I don't even need a calculator to do this. 30 plus 6 is 36. 30 minus 6 is 24. Now I can use my special pattern to solve this. I can square my first term. 30 squared minus 6 squared. Well, 30 times 30, I can do that in my head as 900 minus 36. That's 864. Don't even need a calculator to do it. You may have one on your homework that looks like this. 33 squared. How would I do that? Doing a sum and difference. Well, if I have a single term, something easy that's going to follow a pattern, this is 30 plus 3 squared, is it not? And now I can follow my pattern. I take my first term and I square it. 30 times 30, well, we just did that as 900. Then 30 times 3 is 90, and I double it, 180. 3 squared plus 9. I have 189 plus 900, that's 1,089. These are fun little puzzles. There's 3 of them in your homework. Give them a whirl.